So let's discuss about two types of motion, uniform motion and non-uniform motion. Observe time and position of A in this particular chart. You will see that the object A covers equal distances in equal intervals of time. In the first 5 seconds, it is covering a distance of 6 meters. In the next 5 seconds, again a distance of 6 meters. So when an object covers equal distances in equal intervals of time, we say that the object is in uniform motion. Now let's observe time with position of B. You can carefully observe that the object B is covering unequal distances in equal intervals of time. So this kind of condition is called non-uniform motion. This kind of motion is called non-uniform motion when an object covers unequal distances in equal intervals of time, or vice versa. That object could cover equal distances in unequal intervals of time. Now, non-uniform motion is a real life scenario. For example, you're traveling from point A to point B. You definitely is going to change your speed according to the traffic conditions outside. Right? Now, let's understand how to draw graphs, how to represent uniform motion and non-uniform motion graphically. This is how we represent uniform motion and non-uniform motion graphically. Distance time graph. A straight line represents uniform motion, whereas a curve represents non-uniform motion. Now let's get back to the previous chart and understand that during uniform motion, that is position of A and time, if you carefully observe the quantity, the physical quantity which is constant is speed. If I calculate speed in various cases, the speed will always remain constant. So from here I can conclude that during uniform motion, the speed of an object is constant, whereas during non-uniform motion, the speed is variable, it keeps on changing. The same thing is represented in the graphs below. If you carefully observe, if we calculate the slope, now how to calculate slope we are going to learn in the videos coming ahead. Now, if I calculate the slope of this distance time graph for the uniform motion, the speed will remain constant, whereas this is going to give me a variable speed. Right now, just remember that uniform motion is represented by a straight line, whereas non-uniform motion is represented by a curve. Now, what does this graph represent? Just think about it. The time is increasing, zeros, 1, if I just mark the readings randomly, 1, 2, 3, fine. The time is increasing constantly, but the value of distance is constant. Let's say this is 10 meters. The position is not changing with the reference point O or the origin. So time is increasing, but the position of the object is not changing. And this is only possible when the object itself is not moving. Object is at rest. So this graph represents when the object is stationary and not in motion. Now I've combined together all the possibilities of a distance time graph, the blue graph and the red portion of this graph, this till here, it represents uniform motion. We have a distance time axis and there are straight lines. So straight lines and a distance time axis, this distance time graph represents uniform motion. Whereas the curve, the green line represents non-uniform motion. Now this portion, let's say from point A to point B, it represents the object is stationary, it is not moving. The line is parallel to the time axis, which represents object is at rest. Whereas from B to C represents it is uniform motion, but the object is returning because it is coming down. It is returning to its original position. So this is all about uniform motion and non-uniform motion. We'll meet again soon. Thank you.